Hello team, in this video we're going to talk about virtual I/O. So we've seen that full virtualization runs OSs unmodified, and unmodified OSs will access input and output devices. For example, one of the first things an operating system does when it's booting the computer is enumerate the I/O devices that the computer has. For example, keyboards, mouse, sound cards, GPUs, network cards, disks. So the guest operating system identifies all the input-output devices to manage them. And the operating systems will have device drivers to control these input and output devices. And if the hypervisor gives a guest operating system permission to control an input-output device, then the guest operating system can do whatever it wants with that device, say encrypt the whole hard drive. So how do we prevent this? So the hypervisor needs to allow guest operating systems to perform input and output operations and still guarantee that no guest operating system will perform malicious operations. And even if we consider that guest operating systems are trusted, like they will not do anything malicious, the hypervisor still needs to mediate access to the input and output devices. So the devices must be usable by all the virtual machines running on the server. And the way in which we do this is using virtual input and output devices. So VMs and guest operating systems do not access the hardware I/O devices directly. Instead, VMs and guest operating systems access the virtual input and output devices that are controlled by the hypervisor. And these virtual devices eventually execute the actual input and output operations on the hardware. So let's consider the case that the guest operating system is booting and trying to enumerate the I/O devices. So whenever the guest operating system tries to enumerate the I/O devices, it will run privileged instructions, and these instructions will call the hypervisor. So the hypervisor will see that the guest operating system is trying to enumerate input and output devices, and will respond to these enumeration requests using the virtual I/O device. So the virtual I/O device will compute the response to the guest OS, and the hypervisor will send this response. So the guest OS will get a response just like it would if it was running on the real hardware. So the virtual I/O device will send this response. The virtual device's response is indistinguishable from a response from a hardware device. So the guest operating system gets this response and just continues executing as if a I/O device existed. So here's a figure illustrating this concept. So we have a server which hosts the real hardware. So the server has a CPU, memory, hard drives, and network cards. On top of the server, we run a hypervisor which will manage the different VMs. And then inside the VM, we've seen that the hypervisor allocates CPU and memory to virtual machines, but the hypervisor also generates these virtual I/O devices that the virtual machine will use to talk with the real hardware. So the virtual machine will have a virtual disk and a virtual network card. So whenever the virtual machine wants to perform a network operation, it will use this virtual I/O device. And then you try to send a packet through this virtual I/O device, and the virtual I/O device will call the hypervisor, and then the hypervisor will use the real network card to send data over the network. So the guest operating system thinks it's talking to a network card, but this is a virtual network card. The real network card is in the server, and then the hypervisor mediates access. If there were another virtual machine drawn over here, this virtual machine would also have a virtual network card, and this virtual network card would also use the same hardware network card to talk with the rest of the network. And to illustrate this, so this is a screenshot from the settings window from VirtualBox. So VirtualBox is a hosted virtual machine manager that we can run on Linux and Windows and install virtual machines on top of VirtualBox. And when we are configuring virtual machines in VirtualBox, we can add virtual devices to our virtual machine. And we can add many of them if we want because they're virtual. So here I've added 2 CD-ROM drives to this virtual machine, which doesn't make a lot of sense, and added 2 virtual disks to this virtual machine. And we can also add multiple network cards if we want. So VirtualBox allows up to 4 network cards on a virtual machine. And creating these virtual devices is reasonably cheap because there's no hardware involved. It's just code running on the hypervisor. So there are 2 approaches to implementing virtual devices. One is to mimic existing devices. So you choose an existing network card or an existing disk, and then you implement the virtual device to imitate that hardware device as closely as possible so that the guest operating system can use it. So the advantage of mimicking existing devices is that the guest operating system will likely have drivers for that device already. So the guest operating system will understand how to talk with that virtual device because it's just like a real device that it already knows how to talk to, and then the guest operating system will just work. One problem with this approach is that mimicking existing devices may be a little bit cumbersome because hardware devices, they have a lot of idiosyncrasies and details, and the virtual device would need to imitate all of these details so that it can actually mimic everything that the hardware device does, including bugs and some design flaws. So you need to mimic everything. So this is a little bit cumbersome. Another approach is that virtual devices can implement a new imaginary device. So it can design its own API, and this API may be much cleaner and easier to implement than that of a real hardware device. One problem with this approach is that the guest operating system may not have drivers for this new imaginary device that we are developing. In this case, we would need to install drivers inside the guest operating system so that it can use the virtual device. And this is another example from VirtualBox showing the window where we're configuring a virtual network card inside the virtual machine. So we can have up to 4 virtual network cards. And when we're configuring each of them, we can choose the hardware device or the interface that the virtual network card will show to the operating system. So VirtualBox has support for this PCNet PCI card, and this number here is the chipset. It also has implemented some virtual device that mimics the Intel Pro network card, and it has this SPARA virtualized network which uses the second approach we were discussing. So the SPARA virtualized network has a imaginary device, and we will need to install a driver inside the operating system to use this SPARA virtualized network. So the default is the Intel Pro 1000MT desktop, and it's probably the default because this card might be easy to implement. It might not have a lot of bugs, it might have a clean interface, and because this device is probably common and drivers for this device are available in many different operating systems. So let's consider the example of virtualized disks. So in VirtualBox, like was shown before, we can add many different disks and CD-ROM drives to a virtual machine. And in VirtualBox, because everything runs on one computer, the virtual disk reads and writes to a file on the host computer. So when the virtual machine is using its virtual disk, VirtualBox will receive these input and output requests and write to this file that resides on the host. In a data center, we've talked about virtual disks may be stored over the network on a different server. So in this case, the virtual disk inside the VM will take the requests. It will trigger the network code to exchange data with the data center storage over the network. So this code for the virtual disk and the network code is controlled by the hypervisor, and the operating system will call these functions on the hypervisor to store data. So the operating system thinks it has a local disk, but in practice, what happens when it makes a request to the virtual disk is that data is exchanged over the network. So the VM doesn't need to know about what's happening on the lower layers. It just thinks that it has a disk.